In this video, we will look at model training, model experiment tracking, and model artifact tracking. And we will look at how to do that with MLflow. To start off, we will go to the notebook servers area of Ezmeral Unified Analytics, and we will launch a notebook. The notebook that we are using currently is a pre-packaged image that includes hundreds of packages already included in the image. However, we want to also get a few particular packages that we need for this specific example, and we will do that with Conda Environment Manager. And not only that, we will also create a custom environment, and then we will use that environment for running our notebooks. So what you see here is those specific packages with the specific versions that we need for running this particular example. And we will go ahead and now first create that environment with addition of those particular packages. So we launch a terminal and we will issue the command. Once that is done, then we will be able to use that to create a particular environment which we can set up for our notebooks. So we get the command to create that environment. And we issue it. Okay, so the environment is created. It may take a few seconds to appear within the notebook, but now we will go back to the notebook. And the notebook consists of a few different parts of ML workflow. So it has some analysis and some training, as well as testing, model testing. And as you can see, we need to see the environment that we just created. Now it is visible. So we will select the environment that we created just now as an environment to run this notebook. Okay, so now the workflow to run the notebook will be pretty similar. However, one key difference is that within the notebook, what we are doing is we are registering one new experiment with MLflow, and this is done transparently. The authentication with MLflow included in Ezmeral Unified Analytics is done through SSO. So underlying there is a Java Web Token, JOT, and that web token is used to authenticate with the MLflow. So we will show, now we go to the MLflow UI, and we are able to see the new experiment created. As you can see, the experiment is currently blank. There are no training runs or anything else registered against this experiment. So this will be the experiment that we will use for recording various training runs. So the way we are going to form different training runs is mainly for the purpose of hyperparameter tuning. And we will be tracking a bunch of different metrics. So as you can see, we are using a grid search. So we have a bunch of parameters for training, and we will use those hyperparameters and do multiple training runs, and we will track the model artifacts as well as the results of each training run, and we'll be able to figure out which was the best model that we got out of that. So once we launch the training, we are printing out some results here, but those results will also be tracked in MLFlow now under the experiment that we created. So now you can see that the experiment in MLFlow has some entries, and of course we can show some KPIs that we are tracking within the UI. And as the training progresses within the notebook, we see that more and more training runs are registered within MLFlow. And out of all those training runs, we will be able to identify which one gave us the best results. And for that particular training run that gave us the best results, we also are able to see the model artifact, the location of the model artifact. And this location of the model artifact is within Ezmeral Unified Analytics internal S3. For example, we will go to that training run and we will see where the model artifact is saved and what are the different model artifacts. So we can see the model artifact location, and this location is something which we can deploy within an inference service API. And there's a model pickle file as well as some text files on what all requirements are there from a package perspective for running this model. So all of that gets tracked automatically, and we will use that to deploy a model inference API. Of course, we can do some additional analysis about the importance of different features, etc. And we can also ensure that the model can do inference, etc. So now we come to the model deployment part. So this is where we'll refer to the model artifact location, and we will deploy the model as a K-serve endpoint. So let's just look at the particular model deployment manifest that we created, and this will be standard Kubernetes. And one of the important things to note within this will be that the storage URI refers to the specific model that we tracked within MLflow as the model that we want to deploy. So we can just see what the model endpoint is, whether it is deployed or not. And we can see that the model endpoint is deployed successfully. And there's a URL for the storage URI as well as the URL for the model. So now we'll show you how the inference process will work against this API endpoint. So we just select the same kernel, and we will show you the inference process. So firstly, we just create the URL that we need to call, and then what we are going to do is we are going to send two records, and we should get two predictions against those two records for our inference. And as you can see that we do get two records for rented bikes per hour. So that was the entire workflow of how model training can be done, analysis can be done within Notebook, and then the tracking of experiments and model artifacts within MLflow, as well as deploying the model, the optimum model, and then running inference against that. Thank you.